Hello everybody, welcome or welcome back to my channel. In today's video, we'll be seeing another method of synthesis of nanomaterial, that is chemical vapor deposition method. Chemical vapor deposition method, which is used to form carbon nanotubes. So let me begin. How carbon nanotubes are prepared by chemical vapor deposition. Previously, we saw how copper oxide nanomaterial is formed by precipitation method. Now we'll be seeing how carbon nanotubes are formed by chemical vapor deposition method. Before that, I'd like to start off by drawing a diagram. I'm going to draw a very layman diagram. Don't um, judge it. And say here I am keeping like a boat structure. Okay. So now let me begin. So this is a boat which is made of alumina or quartz. And here, this is the catalyst, the pink part. This part is a catalyst mainly of iron or nickel. Iron or nickel catalyst. And this is a tubular furnace which has temperature of about 600 to 1200 degrees Celsius. And here you can hydrocarbons will enter. Here hydrogen gas and here argon gas will enter. This is the main setup. So let me explain what is exactly going to happen. We are taking a boat made of alumina or quartz, and we have a catalyst in it which is of iron or nickel catalyst. Then what is happening is we are making the hydrocarbon enter through it. The hydrocarbon, when it enters the furnace, at 600 or 1600 to 1200 degrees Celsius. What happens is that the hydrocarbon breaks apart. The carbon part goes to the catalyst. It goes on to the catalyst. It dissolves in the catalyst and it slowly forms carbon nanotubes. Once it is cooled, the carbon nanotubes are collected. Now you might ask, what is the role of argon and hydrogen? Argon and hydrogen helps in to carry the hydrocarbon gas, and argon helps to keep an inert environment so as we get the pure carbon nanotubes. Hydrogen helps in the growth of the carbon nanotube from the catalyst, So what's the function of argon and hydrogen? So this is the idea. Okay, let me just quickly repeat. If one more thing is, any hydrocarbon can be passed into this, right? There's many examples also. Say ethylene, any hydrocarbon. Just say a hydrocarbon. If the liquid hydrocarbon is liquid, we have to heat it. Then that vapor is passed into the furnace. So when we heat if it's a liquid hydrocarbon, then the vapor of we heat it, and its vapor is passed into the furnace. If it's a solid, then it has to sublime, and the solid to gas, then that can be passed into the furnace. That is one thing. And now this basically, what did I say? I'll just quickly sum up. We have taken a hydrocarbon. The hydrocarbon is going to go to the furnace 600 to 1200 degrees Celsius. That's going to break apart. The carbon part is going to go to the catalyst. The boat is made of alumina quartz. The catalyst is made of iron or nickel. The carbon part, after it breaks down, it's going to go to the catalyst. There it's going to dissolve, and then carbon nanotubes are going to be formed. Small carbon nanotubes. After cooling, you can collect the carbon nanotubes. Why is hydrogen and argon used? Hydrogen and argon are used to carry the hydrocarbon to the furnace. Argon helps to keep an inert environment so as to get the pure carbon nanotubes, and H2 that helps in the growth of the carbon nanotube from the catalyst. That's it. Now there's two mechanisms which is followed here. One is top, sorry, tip growth, and one more is bottom growth. How will you remember is that this is being spoken with respect to the catalyst. In tip growth, what happens means the catalyst is going to be at the top and the carbon nanotube is going to be formed below it. The carbon comes on the catalyst, it dissolves in the catalyst, and the nanotube is formed below the catalyst. This is the catalyst, and this is the nanotube here in this case. Okay, and the catalyst is what we know, right? Iron or nickel. Initially, the catalyst will be like this. This I'll do a little better, like this. Initially, it'll be like this. When the carbon nanotube comes in tip growth, what happens? The catalyst is sent up. In bottom growth, what happens? The catalyst remains attached to the substrate, in the sense the aluminum quartz, and the carbon nanotube grows above it. This is a nanotube, and this is the catalyst. That's it. And where is it used? In flat panels, bone grafting, tissue grafting, in light emission, in making of composite materials, display systems. Okay, I remember any two three display systems, bone grafting, tissue grafting, composite material. Okay, that's it. So that was about this. It was a very simple, easy topic. I've not explained it in too much theoretical. I've explained with the help of a diagram and simple, explanation. So I hope I've covered everything required. And thank you for watching. See you in the next one. Bye bye.